Okay, so that's one. Then we could look at the next pulley. Let's call this pulley at C. Now at the center, there will be a force. Then on this, there's going to be another force. Then, since C is a pin, so there should be two reactions, Cx and reaction Cy. Now, the cable goes over, so that means there's another force in that direction, and that's going to be T, because it says the same rope which goes over, so this end will have exact same tension T. It's going to be T as well as T. We just found T as 350, so this will be 350 pounds. Now this force is the same as this force, so that's T, that's another 350 pounds. And this is also the same, so that's another 350 pounds. So that's what you have as the free body for the pulley at point C. Now we're going to sum the force in X. That should go to 0, and you get Cx minus 350, that's 0, or Cx becomes 350 pounds. Then you're going to sum the force in the y direction, that should be 0. You get Cy minus 350 minus 350, that goes to 0, and that gives you Cy as 700 pounds. So those are the forces at point C, and those are really the reactions at the pin which attaches the pulley to the rod AC. Now I can come back at this point. So that's where the pulley is. Now at the center, there was a reaction Cx. So you'll have exact same reaction Cx as 350 pounds. See, this went this way, so on here it's the same magnitude, but it's going to go in that direction. Then you have a reaction going up, so you'll have a reaction going down. It'll have the that's Cy, and the magnitude is same as 700 pounds. Because you took the pulley out from that point, so you need to place the forces which are exerted by the pulley at this point. Now we still have one more pulley to work with. That's pulley at B. Now pulley at B, there is a force in that direction, and that's the same as the tension this one. So that's T, that will be another 350 pounds. Then you have at an angle, same rope, where this angle is 60 degrees, and there will be T with the same thing as 350 pounds. So those are the two forces at the pulley at point B. So at the center, there will be a reaction in that direction. Well, let's say that's going to be a reaction opposite to that. Whatever you have in the horizontal direction, there should be opposite reaction. That's going to be 350 pounds. So that will balance the force in X direction. Then you have a force this way, so you'll have a reaction this direction, and that should be another 350 pounds. So those are the forces at the point B on the pulley. So when I come here, if there is a force in that direction, there will be a force in that direction with magnitude as 350 pounds. Then you have a force going up like this, so there will be a force in the opposite direction, and it should make the same magnitude as 350 pounds, and the angle it should make with the horizontal should be same as this angle. That's going to be 60 degrees. So that basically completes the free body diagram for the rod. I mean, what you have done so far is you have shown the reaction at point A, you have shown the effect of the connecting member BD, you have shown the effect of the pulley at point B, and then you have also shown the effect of the pulley at point C. Plus, the way this diagram is drawn, there are only three unknowns. You have this reaction as a known, you have this reaction as a known, and you have this free body or the force FPD as another unknown. So you should be in a position to solve all these forces, and the easiest thing would be to sum the moment about point A, and that should add up to 0. So you get FBD, you take its sine component, the sine 45, you multiply this by 4, so that's the distance. I mean, on here, distance really is this part is 4 feet, and this part is 4 feet. When you take component